Cool. Everyone can hear me? Hi everyone. So here's the plan today. Oh, let me just wipe the camera so it's nice and clean. So here's the plan today. We're gonna be exploring the new React Concurrent mode that was announced late last week at React Conf. The plan is that I've played with an old version of the React Concurrent mode stuff with back then it was called time slicing. I think that was the same thing. And then React Suspense, which is a similar API specifically for data fetching. I played around with that like a year ago, so I kind of know what's going on, but obviously there's been another year of development, and now we have, hey fuzzy buddy, now we have an officially experimental mode of React Concurrent mode. So the plan today is to kind of go through their documentation, see what they say, and try to build a demo app or something like that. Maybe, yeah, because that's how I learn best. So I wanted to do this research live because I think that's an interesting approach, and it's better than me holding up somewhere and figuring it all out. I like to do it interactively, so you can ask me questions, we can go through it together, and you can give me ideas for an interesting demo or whatever, and then it's going to be an article later on this week when you get it in your emails. So the basic premise of concurrent mode, as far as I understand it, let me zoom this in a little bit, is that it's like the docs say, it's a new feature set that, as Dan Abramov called it on Hacker News, is a completely new coding paradigm, which is really interesting. But basically it boils down to, from what I last remember, it boils down to being able to render a promise so that you can create a React component that then renders something while it's waiting for a promise to resolve, and then renders something else when that promise is finished resolving. So we're going to be exploring in Code Sandbox, and we're going to go from there. So version control is a metaphor, blocking versus interruptible rendering, blah. I don't really like to read long intros, so filterable product. So, apparently one nice thing we're getting is that we're also going to be able to interrupt rendering. Yes, so rendering will be interruptible. This means when the user presses another key, React doesn't need to block the browser from updating the text input. These are kind of some demos that we've already seen in the past, which was really cool. And it can let the browser paint an update to the input and then continue rendering the updated list in memory. Those are kind of, this is like if you're filtering a list of things and you have to type. I feel like we've already had some of this stuff live in React Master that was just kind of working for us without having to think about it too much. But let's see, working concurrent mode is like working on a branch. Nice if React would stay on for a little longer and skip the bad loading state before showing the new screen. Okay. Concurrency. In concurrent mode, React can work on several state updates concurrently, which is like branches in Git or whatever you're used to. For CPU-bound updates, like creating DOM nodes and running component code, concurrency means that a more urgent update can interrupt rendering that has already started. That sounds promising. And for IO-bound updates, where you're fetching code or data from the network, concurrency means that React can start rendering in memory before all the data arrives. Now that sounds really promising, especially in the context of data visualization or something where you are loading very large data sets. That could be really useful. The way you use React is the same, so that's great. Concepts like components, props, and state fundamentally work the same way. When you want to update the screen, you set the state. Cool. And then it uses a heuristic to decide how urgent an update is and lets you adjust it with a few lines of code so that you can achieve the desired user experience for every interaction. Okay, we're not going to read the research thing. So let's try playing around with suspense for data fetching. Now obviously this is all experimental APIs that we're playing with, so don't use this in production yet, but you're allowed to use it for demo apps or for playing around, which is basically what we're doing right now. Okay, so they're saying that React 16.6 added a suspense component that lets you wait for some code to load and declaratively immediately skips the... Yeah, look it, that's exactly how I like to read documentation. I like to skim and then play around with experiments, and then when I don't understand what's going on, go back to the documentation, right? So, okay, this lets us show a spinner while we're waiting for something, and okay, so that's the suspense. I kind of missed that was already out, or one version of it was out. To declaratively wait for anything else, including data. What is suspense exactly? What suspense is not? That's more useful. It's not a data fetching implementation, so we still have to build that, and it does not couple data fetching to the view layer. What it lets us do is it lets data fetching libraries deeply integrate with React, which is useful, and orchestrate intentionally designed loading states, which is extremely useful. So avoiding race conditions, yes. Okay, this is one of the big problems I've had with UIs, is when you have like 5 different requests that you have to render and wait for all of them to finish. This stuff could be really cool. The code demos on this page use a fake API implementation rather than relay. What if I don't use relay, which we aren't using because we don't have it? Suspense is not currently intended as a way to start fetching data when a component renders. Rather, it lets components express that they're waiting for data that is already being fetched. Unless you have an idea for a solution that helps prevent waterfalls, we suggest to prefer APIs that favor or enforce fetching before render. The current documentation for Relay Suspense API doesn't yet dive deep into preloading, but we plan to publish more about these techniques soon. Traditional approaches. So we've all done fetch on render, which is you render a component, you run use effect, and then you wait for something to load and you display stuff. Fetch then render, which means when you start fetching data first and then you load the next screen when you can. Render as you fetch, start fetching all the required data for the next screen as early as possible, and start rendering the new screen immediately before you get a network response as data streams in. React retries rendering components that still need data until they're all ready. Okay, that sounds cool. Okay, so on the other chat room, Leo is saying that suspense was out for code splitting, which is true. That's what it was out for, and I kind of missed that because I wasn't paying attention. So simplified solutions tend to be blah. You fetch on render using suspense, not using suspense. This is something we've probably all done. You run an effect, you then fetch something, and you when it's fetched, you render stuff. Profile page and profile timeline components doesn't start fetching until after the component has rendered on the screen, and this leads to a problem known as waterfall, because you load the profile page, you run an effect that fetches data about the user, you're loading the profile, and then you render the profile timeline, and that then calls the next API, and then you're loading and you're loading, and you're basically going in a waterfall of loading states, which looks terrible if you're a user. Let's go try it on Code Sandbox. So I think the best approach, why copy the link address? So I think the best approach is going to be to go through their Code Sandboxes and then try building our own, because at least for me, that's how I learn best. So Giron, loading profile, then it loads posts, and then it shows the stuff. And it's using this creates a waterfall. Okay, start fetching posts, blah blah blah. Fetch then render. You fetch both things first, and you wait for both APIs to finish, and then you kick off the rendering. So again, you load the profile page, load both things, and then it works like this. Let's see. So kick off fetching as early as possible. You fetch profile data, you get the promise, and then you say once you get both of the promises, you set the user and you set posts, and if the user is not set yet, okay, let's try the Code Sandbox for that one. And let's see, that will loading profile ring, and then it loads both of them. Okay, that's cool, because it's doing both things together, and that makes it work a little bit better. Then render as you fetch. this is using suspense. In the previous approach, we fetch data before we called setState, start fetching, finish fetching, start rendering. With suspense, we still start fetching first, but we flip the last two steps around. So we can start fetching and then immediately start rendering, and you finish fetching. We don't wait for the response to come back before we start rendering. We start rendering pretty much immediately after kicking off the network request. Okay, so let's try to understand this example. Let's see the result first. Oh wow, this one has 5,000 views. Nice. Okay. So we load it, loading profile, loading posts, and then we get everything. I don't understand what suspense got for us here. This still looks like the waterfall for me. When we render profile page on the screen, we already kicked off the request in fetch profile data. So let's see, fetch profile data, it starts immediately, but we're rendering a suspense which has two fallbacks. So we're rendering a suspense inside a suspense, and both of those load stuff, and then things happen. So React tries to render profile details. It calls resource user read. None of the data is fetched yet, so this component suspends. React skips over it and tries rendering other components in the tree. It tries to render profile timeline. It calls the thing. There's no data yet, so this component also suspends. There's nothing left to try rendering because profile details suspended. React shows the closest suspense fallback above it in the tree, which is the loading profile one. As more data streams in, React will try rendering, and each time it might be able to progress deeper. When resource user is fetched, the profile details component will render successfully and will no longer need the loading profile fallback. Okay, so this suspense itself as a mechanism is flexible and doesn't have many constraints. Product code needs to be more constrained to ensure no waterfalls, but there are different ways to provide these guarantees. Yes, so it's like Leo is saying in the other chat room. Let me cross-pose that. So this is what Leo said, and Leo is on the right track here. Basically, the idea is that with suspense, we're loading things in parallel. So what we're gonna try to do, suspense and race conditions, that's blah, race conditions with use effect, of our original fetch in effect, blah, try race conditions with component update. Requests from the previous profiles may sometimes come back after we've already switched the profile to another ID. I think I've seen that happen before. Solving race conditions with suspense. Fetch profile data, try it on code sandbox. We're not waiting for the response to set the state, it's the other way around. We set the state and start rendering immediately after kicking off a request. As soon as we have more data, React fills in the content inside suspense components. Handling errors. When we write code, so with suspense, we don't have to wait for promises to start rendering, which means handling errors becomes kind of difficult. Then you have to use error boundaries and stuff. We now cover the basics of suspense for data fetching. Importantly, why suspense works this way. Okay, so here's where I'm gonna start experimenting a little bit. I'm gonna try to play around with this example so that it loads in reverse. I want it to show the posts first and then the name of the person second. I think that would be a useful experiment to run here. Let's see. So I'm gonna fork this thing, this example that exists, and let's see if we can go mess with how the fake API works and see what that's doing. So fake API JS. We have fetch profile data, which creates a user promise and a post promise. Suspense integrations like Relay implement a contract like this to integrate with React. Real implementations can be significantly more complex. Don't copy paste this into your project. So that's going to also be something that we have to try to understand. Fetching user. Okay, so we have the suspender, which creates status pending, status error, status success. I think that's what suspense is hooking into. How can we see the actual implementation of suspense? Let's see if we can find that. That will help me understand what pending, error, and success are all about. So if we go into React, where is it? Just React.js. How do we find React? React in all of GitHub. Facebook React. Wow, they have a lot of stars. So Facebook React, if we go into packages, suspense. Actually, what if we just search for suspense? Suspense like this in this repository. React Fiber suspense context. I just want to find first the implementation of suspense. But how would I find that? That's the problem. React reconciler. Okay, what if we go, is there just a React package? Okay, they're all React. Okay, here we go. React. Then we have source. And there should be suspense in here somewhere. React hooks, React lazy, React shared internals, suspense. Oh, okay, I know what we can do. We can go into index.js, no, React.js. This would export suspense somewhere, right? Suspense, why is it suspense list? Suspense, React suspense type. So that's what we're exporting. Where do we get React suspense type? From React symbols? Okay. I have definitely not spent enough time in the React code base. That's annoying. And also kind of disappointing on my part, because I totally have no idea how React works internally, and I wish I did. Okay. So I'm going to assume that pending, error, and success gives us states for how the promise is currently doing. Right, wrap promise. Then we have fetch user, which returns a promise with a set timeout of 1000 and then returns Ringo star. Then we have fetch posts, which returns with 2000. Now let's see what happens if we invert those. Then it should give us the inverse behavior. No? Okay. So then what happens is that we're waiting for the user to show up before we show the posts, which makes sense. So if we go into index.js, that means we're rendering profile details and then profile timeline like this. But if we put them parallel, so if these are parallel, then we can, there we go, okay, which looks weird, right? So what if our fallback for loading posts is just null? Okay, that kind of gives us a weird UX experience, but at least we know that these things are completely separate. So then what we can do is we can, I wonder if we could use this to live stream data into the visualization. That would be an interesting experiment. So we could have a visualization of live streaming data. Let's try making that. And that will help us understand right? Yes, I think that will help. At least it's gonna help me understand how all of this works a little better. So we share, no, not share. Let's try making it from scratch. So we're gonna make it from scratch, and we're gonna call this. So what do we need? We need to have the right version of React, which is the experimental version. So here we go to, how do I set this to experimental? How did they get 0, 0, 0? Okay, let's see. If I go here and I click this and I scroll all the way down, I get experimental F6, experimental 5F. I don't know how those work. Experimental 5, let's go with F6 because why not? So we then need the React experimental as well. Experimental F6. So this should give us suspense and stuff. Now let's give it an experiment to see if suspense can work for streaming large data sets into a React app, right? Okay, so we've got that. Then I'm going to, let's create a new, let's build a, let's do this, fake streaming data into React with suspense, like that. Streaming data into React with suspense, and then we're going to start with just a list of data points. So how should we do this? We should create, okay, let's do it like this. Suspense fallback is going to be, let's say h2, loading, like that. And then what else does suspense have to do? Then we need to render something. So we're going to render our data set like that, right? Is that how this worked? So profile details, and then we have a resource user.read. Interesting. Okay, so we're gonna have to create a fake API. Let's make it like this so it's easier to copy pasta. And we have the docs here, and let's see, let's call it a data list for now. We're going to fetch data from fake API. Then we create a resource, say const resource equals fetch data, like that. So that starts fetching data immediately as soon as we load the page instead of waiting for it. Then we go here, let's see. So where do we use oh, I get it. So the resource is defined globally, which means we don't pass it in as either props or anything like that. We create a data list here. So we say const data list equals a function like that says const data equals resource.data.read, like that, and it returns a, let's do a list for now. le key equals d.id. Oh, we need to map actually. The data.map, we get that d.id, and we post d. What should we say? Name, time. Let's do d.id as well. Okay, so this should give us a list of our data as we get it. Let's also import suspense from React. So we get suspense, and then for fetch data, we're going to start with Dan's implementation from here. So let's see, fetch data. Come on. Fetch data, new, we called it fake API.js. Now let's see, fake API.js needs to export a function called fetch data, and that function is going to, I know what it's going to do. It's going to, we're going to, okay, we'll see what we're gonna do. We're going to create a let data promise, which is going to be called, let's call it fetch list, and we return, what do we return? We return, did we call it data? Data.map resource data read. Okay, so we say data wrap promise of data promise. So right now I'm just typing things over, trying to figure out how they fit together, and then we're going to turn this into a fake so then we're going to basically turn this into a fake streaming API. So I'm gonna copy paste this. Okay, so suspense integrations, like we really implement a contract like this to integrate with React. Real implementations can be significantly more complex. Don't copy paste this into your project. So we obviously copy pasted it into our project. And then we say function fetch list will be fetching list. And the reason I'm fetching a list first is because we're going to use this to return essentially a list of promises. So ideally we would first know, actually we can get a count. That's usually fast. So you get a count and then you stream additional data for the count in, and that would be cool. Yes, so we get a promise that resolves after some time, and we console log fetch list that, and we resolve it with, let's say, fetch count count promise. So this is basically, the idea is that you would have an API that very quickly returns a count of all of the data that you need, and then you keep loading more additional data points as you go. And I think that's going to be, okay, count promise, fetch count, fetching count, and fetch count, and we resolve with, let's say, 10,000. Let's resolve with 10,000. 1, 2, 3. Let's resolve with 10 first. We start with 10 because that's going to be the easiest. Okay, so we return that. We resolve. Oh, we need to wrap it in a timeout. Set timeout like that. Bam. And we set that timeout for 1 second. Okay, and now we go back to our index.js, and the index.js is going to get count equals resource count read, and we create a new array that is the length of this data set. How do we create an empty array? Let's see. New array. Come on. So new array 10 fill with null, right? Perfect. So we create new array count, and we fill it with null like that. And then what do we need to do with that? We need to render. Let's start with just a count. So we're going to say this is the indexed element, loading, and then it shows 0, 1, 2, 3, 4, 5. Perfect. So this gives us, this is now rendering with suspense, and it's working nicely, which means the next step can be so then how do we fake stream this? And we want, once we want to basically render each of this as a suspense of the indexed API. Yeah, something like that. Okay, let's try that. So we're going to have a suspense here with a fallback of, it's going to render just a, let's say a dot or 3 dots like that. And we get the index, and then that renders immediately, because what does this need to depend on? We're gonna render okay, so this is going to be essentially rendering the indexed element of the array. So we're gonna call this data item, right? Data item, which is going to get a prop of let's say index equals I, and then we create const data item equals a function that gets the index and says const item equals resource dot item. Then how do we oh, I know what we gotta do. Then we gotta, here where we have the count, we would have items. So it would say dot items of index dot read like that, and it would return a list element with yes, so suspense with key equals I think, and it would return item dot, what should we say, each item would have an ID, right? Like that. So that loads, and now it fails because we don't have the items yet. So we go here. Hey Candy Cane, I do actually feel heavier because I ate a lot this weekend and I got fat. So yes, I feel heavier. Well, let's see, items equals, how would we get, we would wrap a promise of items promise. Now how would we know in the items how big of an array we need? Because now this should actually be, let's see here. So we fetch the count, and the count is going to be resolved as 10, which is currently hard-coded. So what we can do, promise pending, so promise then status becomes success, otherwise it's pending. So what we can do, I know what we can do. We can make this a double wrap promise. So we're going to resource.items.read index.read. And I think that's going to break everything, but we're going to try it anyway. So this is going to be a wrap promise, items promise. And then items promise is going to be let items promise equals fetch items with the count promise, right? This is going to be terrible. So then we have function fetch items, which is going to get a count promise. So fetch items with the promise of a count. So count promise. Here we have a it's basically here we have a set of requests that depend on data from initial request, which is kind of messy but realistic, right? So fetch items, let's say console log fetching items, blah, and we would say return count new promise resolve blah, and that promise, what it does is it waits for fetch items. So fetch items, then it gets the it waits for count promise. So count promise, then it gets the count, and with that count it can, what can it do with that count? With that count it can then create an array of new promises that fetch data for individual parts of the thing. In theory, yes, let's try that. So count promise, and then we have new, then we resolve this with a new array of that goes up to count, and it is filled with null, and then we map over that and we get, let's say, an index like that. So if anyone gets lost at any point, I know I'm feeling a little bit lost right now, so please just please ask questions, because otherwise I'm just gonna keep going and I probably already lost you a long time ago, but who knows. So create a promise for each individual item request. So we're creating a promise, which means we return a wrap promise for fetch item of a certain index, right? And then we have a function fetch item, which gets an index and returns a new promise that will be resolved after a set timeout of, let's see, set timeout of just something, and we're going to say math dot, let's give it a random, yes, math dot random times 1000, no, times 100, and we're going to resolve each of them with their index, like that. So element, so how did we read them? We have items read, and then we have item.id. Let's give it, let's just say item, not .id or anything. We're going to say item.i, and let's see what happens. So it's loading, then it loads dots, and then this fails because we don't have an item, we have an index. Cool. So now, even though they're at a completely nice, okay, so that's pretty cool. So we're basically making a bunch of requests for each individual item and rendering those. So that's cool. And Suspense made that surprisingly easy to build. Now let's try what happens if instead of resolving with 10 elements, we resolve with 100 elements? That still works. Cool. Okay, what if it's 1,000 elements? Then it's still gonna work, but it's going to become very difficult to see. So the next step is going to be turning this into a scatter plot, because I like scatter plots and they're easy to make. So we've come this far. Streaming data into React with suspense. Let's add a little paragraph of explainer. Each data point is its own request. Rendered with LT suspense. Rendered with suspense. In theory, this lets you render large data sets, but you would probably want to group multiple data points into the same API request somehow. Okay. But it does make for an interesting demo, at least, I think. Streaming data. Okay, so now let's show the data list as a scatter plot. So I'm gonna add D3, because that will make my life a little bit easier. D3, and then we are going to, what do we need from D3 actually? Do we even need anything from D3? Fallback is ... for each item. Instead, the fallback is going to be a null. So loading, and then they just start rendering. And we're gonna wrap all of this in an SVG with a width of 100% and a height of Candy cane. A quick recap is that we're trying to replicate basically Dan Abramov's demo from the documentation and making it more complex. What Fake API does is that it creates a bunch of promises that resolve at random times, because that kind of simulates what would happen with the real API. And then we are rendering each of those requests with a suspense, basically with a suspense component, which lets us suspend React rendering while we wait for a request to finish. So we can basically start our requests as soon as we can, instead of only once the component is loaded, and that lets us then render as soon as, basically as soon as the data is ready, we can render that data point immediately. So that's kind of what we're orchestrating here with a very over-the-top example, but I think it would be really interesting for data visualization and stuff like that, because that's how I'm used to thinking about React. So let's give it a width of, let's say, 300 and a height of 300. That's going to be our SVG. And then each of the elements is going to render a circle that is going to be at CX. Oh, we're not even going to need we're not going to need D3, so I'm just going to remove it from here. So we have, no, we're going to need D3. D3 is going to make our life easier. D3, even if we're just using it for some scales. So we're going to say circle CX equals, how would one implement this fake API with a real server? That is a great question that I will get to as soon as I make this work. So circle CX will be x scale of item.x, and CY is going to be y scale item.y, like that, and we close with circle. Now we need the x scale and the y scale. how do we get the X scale and the Y scale? Let's try just building them here from scratch. So we import asterisk as d3 from d3, style CSS, blah, then const X scale equals d3 dot scale linear with a domain. We know the domain goes from 0 to 1 because it's going to be random data. We know math.random generates in 0 to 1 range. In 0 to 1 with a range that goes from 0 to 300 because that's the width, or let's call it max width. Max width would be cool. Then const Y scale equals d3 dot scale linear dot domain 0 1 dot range not domain, I said range 0 to 300, like that. So then we have to create these items. So we're going to resolve with, let's see, X is going to be math.random and Y is also going to be math.random, like that. So we should now get a streaming visualization of like a simple scatter plot, but it's not working because the above error occurred in the circle component. What is wrong? Cross origin error was thrown, yes. Objects are not valid as a React child. Not trying to render an object. Okay, so what am I getting wrong here? Domain, range, domain, X scale, item X. Oh, like that's the problem. Because we don't actually need this. Say we just finish the thing and we give it a radius of 3 pixels. Voila. Nice. Okay. So let's give it a radius of 4 pixels instead, like that. And then another thing we can do here is that we're going to give it a bit of a nicer style. So we're going to say style is going to be, fill is going to be RGBA. Let's get a nice RGBA color. What's a nice color that we can use? Pretty color. 36 beautiful color palettes. Okay. Beach towels, perfect. Let's use, which one? Ooh, light pink. That's a new. Beautiful blues. Okay, that's perfect. We're gonna use this one. Go back here. And we fill that. Then we say fill opacity equals 0.6. No. 0.2. Why does fill opacity not work? That used to work. React fill opacity. Seriously? Hey Thomas. Oh, F87. What's, I can still change that to F87. What's F87? Okay, we can go with that. It came from the chat room, so it's gotta be great, right? Closing in favor of. I know this has already been solved. I am just forgetting what's it actually called. Fill opacity, come on. Fill opacity. Why is that not working then? Maybe it is working and I'm just not noticing that it's working. We can verify that. So if I go here and I click this thing, come on. Circle. What is your CSS style? Okay, what if we do it this way? Fill is going to be hashtag F87, and then fill opacity is going to be 0.5. Ah, there we go. Okay, now it's working. So fill opacity is that. Cool. And now we can make this return even more data points. So let's see how many. Should we do 1000 data points? Yeah, let's do 10,000 data points. Cool. Okay, so then once we have 10,000 data points, that is obviously not going to work very well. So let's try batching them together, which is how you would usually do this. You would have like a paging request that requests 100 items each. What's CPU usage before batching? Well, the problem with CPU usage is that I am currently using 200% of my CPU for the live stream. So Brave doesn't even really come close. So we're not batching them yet. Okay, so oh, tap specific insight. Oh, but I'm using Brave, so I don't actually know how to get to the task manager. But let's see. I'm gonna do it this way. 10,000 data points, each with its own request rendered via suspense via suspense. In reality, you would batch these like with paging. A ref equals here. How can I use 200% of my CPU without it crashing? That's a great question, Candy Cane. And the answer is that this is I think a quad-core machine, so it can go up to 400%. Now let's fork this and make and I'm gonna do what Lookid asked for stuff. Later, when I'm not streaming as well, I'm going to do some additional research and write a recap article of what we built. 10,000 data points rendered via suspense in batches of 100. For a non-batched example, here. Okay, so now we've got this. Click back. So I'm obviously already preparing this for when it inevitably becomes an article and I want people to be able to navigate around. So, and you can also see that look at this. It's we managed to find a code sandbox bug where it's rendering the wrong example. See, Festive Lake, Dark Waterfall, and in Dark Waterfall we changed the copy, and code sandbox is rendering the new example from the future because I just clicked back. That is so funny. So let's go to Dark Waterfall. Save. No. In here, save. Dark Waterfall. Leave. Okay, I'm gonna have to verify that that actually saved correctly afterwards. Lucas Floriani, I don't know if concurrent mode is going to be it's going to be stable in the next version of React, but it's definitely going to be soonish, I hope. It's hard to say because I'm not on the team. I know that they finally, after us waiting for it for like a year and a half or 2 years, they finally put out a experimental version. Ooh, 7AF and 7FC. We can do that. Let's see if this manages to load. My computer is starting to have trouble. So now we're going to change this. So it's going to, let's see, instead of going up to count, it needs to go up to count divided by 100. And then it's going to, instead of rep promise, it's going to fetch batch. Come on, you can type. Okay, computer's being silly. It's giving me trouble typing. Candy cane, yes. As far as I know, the React team is just like 5 people or something. Come on, come on. Okay. My computer is starting to become a huge problem. Fetch batch of an index. Do we need the index? Yeah, let's use the index, whatever. And here we resolve with a new array of 100 items, which we fill with null, and then map. Okay, typing. I'm waiting for the typing to actually finish. There we go. You see how it all showed up all at the same time? Okay, index blah, like that. Okay, so we're now resolving in batches of 100, which means here when we're rendering, index.js, click, come on, you can do this. So I think I'm running too many things all of a sudden, and the computer is getting very frustratingly confused about what's going on. $10,000 data points, rendered blah, come on. And then here we now get not just an index, right? So we still get an index, but the elements this is now going to be called a batch. So we're gonna have to render a bunch of them. So we're gonna say, come on, come on. It would be nice if I could tell Code Sandbox to stop running things with basically just like let me finish writing the code and then run it, because you are literally just destroying yourself by firing a bunch of errors. Batch dot map item blah. Okay, I think this is now gonna work. Oh no, it needs one more parenthesis. Come on, type it out. Yay, okay, I think I managed to write the code. Now let's see if it actually works. Nope, the console is still freaking the shit out. So I'm going to just copy this, close it, and go into a new tab so that it, you know, refreshes, gets a breath of fresh air. Okay, let's see. So we still have math gen blah. We go through the batch, and our fetch API, our fake API is now returning batches of 100. Yes. batch. Okay, reload. Let's see what happens. And it crashes. Why? Okay, so now the problem is that I can't really tell what's going on anymore. The gear icon in preferences. There's preferences. I think we broke Code Sandbox. Yeah, there's not. I can't do anything anymore. Yeah, Code Sandbox broke itself, exactly. Let's see if this gives me any more useful information. So if we go into File, Preferences, Settings, cannot read property, read of undefined. Oh, I know what's going wrong. Yeah, so look, I'm having trouble getting to the preferences to be able to turn that off. Aha. So preview, come on, show me the preview. User settings, workspace settings, I don't know. But I know what the problem is. The problem is that we are still using it when rendering as if it was not returning batches. So we need to divide the index by 100 and then it should work. So here, data item index divided by 100, right? I think that should work. No, the other way around. This is where we have to divide by 100. Ah! Come on, let me type. Right, VS Code copy. Reload. Okay, so note to self, kids. Don't put very large numbers into your demos until you're actually ready for things to start working, because this is painful. We recovered one unsaved file. Well, thank you. That file is broken. Oh, gear icon. Okay, close this. Come here. Just please, like, stay the way you are. We say count divided by 100, and then we here put in the index, and now it should work. Voila. Yes. Okay, see, that works much faster now. So to make it even better, what we can do is give something very nice for Lucas Floriani. So we're gonna use FA7 and F7C. So we're gonna say the fill is going to be F and then hashtag 7AF and hashtag 7FC of, do we have an index? We do have an index of index mod 3, like that. Let's see if that gives us batch colors. Yay! Cool. So that concludes my experimentation for today. To answer Leo's questions in the other chat room, if you were to use a real API, your fetch calls would go here. Let's see, fetch items, URL, this set timeout would be a fetch, and also here IRL, this set timeout would be a fetch. So that would be where your delays come from, and it would all naturally flow from there. And I think this is a pretty cool little example that we got. So I'm gonna I'm gonna play around with this a little bit more. I'm gonna try to dig into the documentation a little bit more so that I can write a better article, and then I'm going to write about our findings and kind of talk about that a little bit and send you all an article if you're on my mailing list, and if you're not, you're gonna have to get on my mailing list and then you'll get the article. So thanks everyone for watching. I hope this was interesting. I definitely had fun building this, despite the slow computer and other technical glitches. So yeah, thanks for watching, and I will see you again next time.